Our next example, you're going to be given a rectangular equation. So let's use 3x minus y equals 6. And we're going to convert it to a polar equation. For a polar equation, we definitely want it only in terms of r and theta. Again, rectangular, you're given your x and your y. We want our polar equation to have only r and theta. What we're going to do is get rid of the x, get rid of the y, using those equations that we had from our past. So x equals, again, r cosine theta, and y equals r sine theta. It'd be good to memorize those to help you for your test if you have one. Again, we're going to plug in r cosine theta for x. And we're going to plug in r sine theta for y. Drop down your equals 6. And technically, you're done because now you have an equation with no x's or y's. You just have r's and thetas. However, if you're trying to prepare for a multiple choice test, if you're looking up an answer in the back of a textbook, they usually won't, not always, but usually won't leave it like this. They'll usually solve for r and then have the equation in terms of theta. And again, the directions would say express the equation expresses r in terms of theta. So what we're going to do to fix that is we're actually going to factor r out. When you factor r out, you're going to be left with 3 cosine theta minus sine theta. And again, to isolate r so that you have r on one side and then theta's on the other, you're going to divide this out from both sides. So you actually get 6 over 3 cosine theta minus sine theta. So now we have an equation, polar equation, where it expresses r in terms of theta, and you no longer have your x's and y's. For part B, let's see if I can fit it on here, we're going to use the equation x squared plus the quantity y plus 1 squared equals 1. So that's going to be our rectangular equation, and I want to change it to polar. Same thing, we're going to plug in these same two equations for x and y. So x equals r cosine theta, y is r sine theta, and again I'm just plugging in for y, so I still have a plus 1 squared. On this one, in my class we call it shower of the power, so we're actually going to rewrite this as r squared cosine squared of theta. Over here, because it's a you have a plus, you can't technically shower the power if you want to call it that. You can distribute it out, or again we call it FOIL. So when you rewrite this twice, you can then, it's probably easier to see all the terms, but I'm just going to get going here. 2r sine theta plus 1, that's a theta, equals 1. Now I have this long equation. If I were to subtract 1 from both sides, those would go away, leaving 0 over here. And we're going to get a little bit creative. I'd like to factor the r squared out of those. So you're left with cosine squared theta plus sine squared theta. Drop this down to r sine theta. Again, because we subtracted 1, you get 0. And right here, you guys might notice that that is the Pythagorean identity equaling to 1. So now we have r squared. Again, this goes to 1. 1 times r squared is r squared, plus 2r sine theta. And if that was just r, we could do this similar to the last problem where we just factor r out, but it's not. So we're actually going to, we are going to factor r out, but it's not going to be as convenient, again, as the last problem, because this is now demonstrating the zero product property. If you have a product equaling 0, you can set them both equal to 0. If I were to solve this equation, I have, again, two equations now, r equals 0 and r equals negative 2 sine theta. And I want to go back to the original problem. It's right here. This is our rectangular equation. If you notice, it does represent a circle with center at 0, negative 1, and radius 1. Kind of like that, informally drawn. So that circle is what we're still representing in polar terms. And so if you'll notice, r equals 0 means if you start, well, if you go out and not, like if you rotate anywhere, because there's no theta in this equation, it's saying that you could rotate to any angle and you're not going out at all because the radius is 0, so you're not going out. So it keeps you right at this point in rectangular terms at the origin. And so if you'll notice, again, this point is included in the graph of the original equation. So because some people haven't learned to graph this yet, this part of the equation is actually included in that equation. So this is actually going to be our final answer. It's just r equals negative 2 sine theta. The last example we're going to work through says convert each polar equation to a rectangular equation in x and y. So again, you're given polar equations and we want to write them as rectangular equations where you just have x's and y's. So some people will be able to do this just by looking at the picture if they were to graph this, and some people like to use a formula. So I'm going to definitely show the formula. It says that r equals 4. Again, you have a polar where you have r. You want just x's and y's. So I'm going to use that one equation from our set of 4. X squared plus y squared equals r squared. And we're going to plug in r as 4. So you get x squared plus y squared equals 16. So that is your equation, your rectangular equation with you have just x's and y's given that r equaled 4 for polar. And I just want to again emphasize that two things are going on. First, think of r equals 4. It doesn't have a theta, so it's pretty much saying that no matter where you rotate around, if you rotate 1 degree or if you rotate pi over 2, or if you rotate all the way, to pi or anywhere, infinite number of places, you're going to go out a distance of 4. And so again, if you were to rotate anywhere, you're going out a length of 4. 1, 2, 3, 4. Again, if we rotate it all the way up, we're going out a distance of 4. And so if you think of doing that an infinite number of times, 1, 2, 3, 4, it's creating, oh, whoa, that's a little off, but it's creating a circle with center 0, 0 and radius of 4, which is nice because it's backed up by this equation, again, the one we found, where from our conics, you have, this is the equation of a circle where the center is 0, 0 and the radius is 4. For the next one, it says that theta equals 3 pi over 4. So I actually want to kind of get a little creative on this. We're going to take the tangent of both sides. So if I take the tangent of this theta and tangent of 3 pi over 4, I'm going to get this right here, where tangent of 3/4 of pi, there's 3/4 of pi. That's going to be a reference of 45 degrees, so my sides are root 2 over 2 and negative root 2 over 2. So if I want to find tangent of 3/4 pi, it's the same as opposite over adjacent, which is just going to be negative 1. So I get to this point. From those 4 equations, I'm going to use that tangent of theta equals y over x. So I'm going to substitute y over x. And if I were to times both sides by x, I get the equation y equals negative x. So again, that would be my rectangular equation, given my polar equation, theta equals 3 pi over 4. And again, it's really nice how, if you actually think about this, it's saying you're rotating 3 pi over 4, so you're rotating 3/4 of pi, so you're rotating to here. And because it's not specifying there's no r, you can go out any length. You can go out 1, you can go out 2, you can go out, 0.5, Or you can even do a negative r, which puts you back this way. -1, -2. And so if you were to plot like all these different r's, an infinite number of them, it creates the line y equals -x. So again, that's really great that it works graphically as well. For part C, it says r equals -2 secant of theta. The first step, we're going to rewrite secant of theta as 1 over cosine of theta. Next, what we're going to do is multiply both sides by cosine of theta. And on this left side, it says r cosine theta, which that is equal to x from those 4 equations. And so you get the rectangular equation x equals -2. So again, your polar equation had r's and thetas, and your rectangular that you've converted to only has x's, no more r's or thetas. So we're done on that one. For part D, it says r equals 10 sine of theta, and we're going to get a little creative. You probably wouldn't know to do this unless you've seen it, but here we're going to see it. So what we're going to do is we're going to actually times both sides by r. So that makes r squared. I'm actually going to rearrange this so it says 10r sine of theta. And next, again, our goal is to get rid of the r's and thetas. So we're going to substitute x squared plus y squared in for the r squared. And right here, we're going to substitute r sine theta as y. Technically, you're done because you have only x's and y's, but again, on a multiple choice test or usually in the back of textbook, they will manipulate this so that it looks a little more recognizable. So what we're going to do is actually subtract the 10y over. And when we do that, it's going to leave a 0. But the next step is I'm going to leave 2 blank spots because we're going to complete the square on the y's. So refresh our memory. To complete the square, you're going to take the b term, which is -10, divide by 2, and square it. So that tells us that we're going to add 25 to both sides. Next, we're going to take drop down the x squared, and we're going to take y squared minus 10y plus 25, rewrite it as y minus 5 quantity squared equals 25. And so this is definitely what most, I guess, multiple choice tests would have the answer as, because that represents a circle with center at 0, 5, and radius of 5.